Hello guys, so in this video I just gonna start going through a set of stuff in like basic or essential math for data science and machine learning, and how we can code this in Python. So this is an this is a starting point for me on this journey. So um, I'm just gonna learn, and you can learn in the process. So you use NumPy here as NP. You have scalar, array, matrix. You use the same np.array, and there is tensor. You use np.random. So these are I guess, the functions that you can call to do something in in Python here to create a tensor. Use np.random.run. Um, so let's run this code and see what we get. So Python linear 1.py. All right, so scalar, vector, matrix, tensor. We just print some stuff. So a scalar, in terms of a tensor, a scalar can be called a tensor, but with a rank of 0, right? So here, if I should do this, so scalar, let me make sure I got a good pen. All right, so in terms of tensor ranking, this is 0. A vector has a rank of 1. It's one-dimensional. A matrix is two-dimensional. A tensor here in gonna be three-dimension, or I should say n is greater than or equals to 3. All right. Now, a scalar is a tensor. A vector is a tensor. A matrix is a tensor. But a tensor is not a matrix or a vector or a scalar. It could be something more, because a tensor has, n dimensions, right? And where n could be 3 or greater, right? Um, so whilst a scalar is a tensor is not necessarily a scalar. Okay, so this is just starting out. So we got some np.random.run will generate a tensor, and array and vector. For matrix and vector, use np.array. You just arrange your stuff in the brackets here with a comma, and that should get you going. Of course, you have like this matrix here. It's like 1, 2, 3, 4, like this. But here you have, right, one square bracket, another square bracket, just looking at the convention. So this looks okay. Let's move to something else now. Maybe so here we have two arrays, right? Not two arrays, I should say two matrices, right? And they're 2 by 2, and we're just printing them. Then we add them. To do a multiplication in Python here using NumPy, you use np dot, and the matrix involved. To transpose, this is cool. You use a dot t to transpose the matrix. And to find the inverse of a matrix, you use np dot linear algebra dot inverse of the term, and then okay, sorry guys, I should just like run it like this and explain some of these things. So if you have a b c d, right, and this is equals to a, so a transpose would be you make your rows into columns, so a b c d. All right, so yeah, row become a column, row become a column, and the inverse of a gonna be 1 upon ad minus bc into da minus b minus c, and you work this out. This is whatever you do in school, some elementary matrix algebra. So yeah, so use a try and except block here. So linear algebra dot inverse. All right. So the identity matrix is, in the case is a square matrix, the diagonals are 1 moving from left to right, and this diagonal is 0. It's like effectively multiplying a matrix by the identity matrix will give you the matrix itself. All right, so what is this saying here is that I should put it like this: I is A times A inverse, right? You can see that from this equation. Okay, so here in Python I have inverse in local. So local mean if this term inverse A was already established in the code above. So yeah, here we're gonna find the inverse of the matrix by using this function here, or these function calls. So you're just checking if it exists, and you're multiplying it by the matrix A, right? And you're doing an identity check to see what you get out. Okay, so we're gonna run this code now, and let's see how it goes. So this is gonna be Python linear underscore 2.py. All right, so we print the matrix 1 2 3 4 5 6 7 8. We multiply, we add them up, right? That works. Multiply them using np dot transpose 1 2 3 4 becomes 1 3, yep, and 2 4, yep. Inverse of the matrix here, and then we did the original matrix times its inverse should be the identity matrix. So we got 1 1, and this is a small number, 8.88 to the minus 16. All right, it's like tending to 0. So I guess we got the basics here of at least setting a vector, a scalar, adding two matrix, multiplying two matrix, finding the transpose of a matrix and the inverse of a matrix, and checking the identity matrix, like the actual matrix times its inverse should be the identity matrix. So I'll stop here in this video, guys, and I'll continue moving through these topics. I guess what I would like to cover in this series would be the following. Like look at linear programming, calculus, matrix decomposition, derivatives, and TensorFlow core, right? Optimization. So this is just the start of it. Okay, bye for now.